Welcome to the world of Stora Hardcore Pro.
Getting recorded. Okay, cool. So, hey guy, am I recording? Yeah, okay. Hey guys, this is, I don't even know what episode this is. This is episode something, of the Devlog series. Today, okay, I'll be straight up. I messed up. I was working on some hand-eye case stuff. And I thought I was recording, but I wasn't recording. So I'm like, to be fair, you haven't missed much, but I explained basically everything I was doing and going to do, which took about 10 minutes, and now I have to redo it, which is a bit shit, but hey ho, what can you do? We'll go again. So, let's start from the beginning. Basically, what we're trying to do here is we've set up some run collision stuff. And so when your character collides with the wall, let's get in the environment real quick. When your character collides with the wall, we want to have, if you're not doing like a parkour animation, that is, you want to have quite a cool collision. Like, you know, like sort of lean forward and like crap, I just collided with the wall, rather than just ragdoll every time, because ragdolling every time would be weird and not very good. So what we've done is Dado actually had, we actually had some animations from where are they? Yeah, we actually had an animation of Toby. They're stopping at the wall. Yeah. So what we're gonna do, and at the moment now, the character, it does that. So we get to the wall. We currently do a line trace from that purple capsule, pink, purple, whatever capsule you see there. We do a line trace, and when it's in that certain distance, it stops at the wall. I'll show you the code for line trace. Here, that's not it. Where is it? That's not it either. Be around it here. Okay, so here we currently do a line trace from the capsule here, and yeah, we do a line trace, single by channel from the capsule down, and then we return the stop distance, and then we play the animation. Actually, this is quite interesting. I did explain this last time, so I will explain now. So we basically enable this collision value. So we say, okay, you're now in the run collision if, once you've done this, we have a trajectory direction. So we do a line trace of a certain distance, and if you collide with the line trace, then you're going to enter the run collision state, and which is going to be done by this. So we set a variable enable run collision to be true, and then we get the stop distance and set the speed and sprint values to be false, because we're now in the run collision state. So basically we do a line trace in front of us every time the locomotion is updated, to see, are we in the run collision state. I'll show you the state machine for that here. So as you can see, we've got run collision, which switches on run collision occurred, which is set from that enable run collision variable in C++, and we gather all these variables in here. You know what I'm saying? We gather all these variables. We gather run collision occurred from has run collision occurred, which gets the value from there. Basically, it's just like methods to get each other, but it keeps them all separate. So yeah, then we enter this run collision state, and then in here, ignore this. This is some crazy experimental stuff I was doing a while ago to practice. Didn't work, as you can clearly see. Here we just play this animation. Now, what's interesting, so what logic I came up, basically, depending on how far you are from the wall, you're going to want to start the animation at different points, because we want the animation to stop at the perfect time, at the perfect distance, perfect spot away from the wall. Like, we want where it stops on the wall to be deterministic. So I was like, well, how can we determine that it's always going to stop at the same point? Well, one way to do it, which I came up with, was we have a start position, okay, and this is where in the animation we start. Yeah, so this is where are we going to start in this animation. So where are we going to start the animation from? And we have, you see this curve here, this represents the distance traveled in the animation. So I was like, well, what I want to be able to say is, however far we are from the wall, that's where we need to start the animation from. Now, initially I'd say, well, just use the curve, but I was not able to find a way to get the time based on a distance value of a curve. So instead, what I did is pretty much the same thing, but just C++. I got the distance from the line trace, which is basically where the character is from the wall. Like we do the trace. How far is the object you hit in the trace from the trace start? Yeah, which is pretty much it. That's what that is. So we set that as a stop distance variable, and then we use a get stop distance function in C++. I mean, we call it in here. Here, yeah. So we use a get stop distance. And so now we have the stop distance, which is the distance from where you're at from the trace to the wall. So how far you need to travel basically to hit the wall. Now what I do then is I then map the range and clamp it, the two values, but I like flip it. So I say, so we have this distance value which can be between 0 and 201, because as you see, that's the distance traveled in the animation. And then I clamp the time from which he moves from 0 to when he no longer is moving in the animation, which is around 0.8. Now he's not moving any further. You see, around this point he's not actually moving any further. I then clamp that those distance values, so the stop distance, to that time. So now we have the stop distance now represents a time in which we're going to start the animation, and I flip it around because the further away you are, the earlier you want to start the animation. So if I'm the maximum distance away, I want to start at the start. If I'm the closest distance away, I want to start when he's no longer moving. Do you see me? So we clamp them two values. So this stop distance basically with this becomes a time in which we want to start the animation. And we set that to the start position, and then we've bound in our run collision state the start position of the animation here to the start position time variable that we've set from that. So that was how that was my way of achieving sort of like, oh, when should I start the animation based on the distance. That's how I achieved it. So it's that, and it works. You know, it works well. We have the trace, it comes up, it starts the animation now, and it stops it at the right time. Now there's a couple things, a couple fixes and the things we now need to do. The first thing we're going to have to do is some hand decay. Now this is what I was actually working on when I thought it was recording, but it wasn't, and I had already sort of explained all this, but I'm going through it again. Now hand decay, I'm going to release a video before this video, so if you haven't seen it, I'll probably put like maybe a little pop-up somewhere here at this point. Let me do a little spin of the character so I remember this is where I need to put the pop-up to watch the video, and it's going to basically just be a quick rundown of what inverse kinematics is, just so you have a better idea of it, so that these videos aren't too long with me explaining some concepts. Yeah, so basically it uses hand decay. We basically give it a target location for the hands, and then it moves the hands to where it needs to be, based on where the effector location, which is where we want the hands to be placed. So what we're going to do is we're actually going to set up a trace from the hands down, and then this trace is going to get the location of where we hit on the wall, well, the flat part of the wall actually, where we hit on the flat part of the wall. And then once we've done that, it's going to get the location of the flat part of where we hit on the wall, and that's going to become the effector location where we want to move our hands to. So what I've done already, as you can see, is I've created some notifiers to basically tell me when to enable and disable hand decay, and that's done basically when I'm at the different points in the animation. So here, the first notifier, I want to enable it when I'm here, which is when he's reaching out. And then I want to disable it when he's pulling back, because we're saying, okay, now we're coming out off of the run collision. So basically at that point, enable it, disable hand decay. And then in here, in the notifiers, basically this just sets the hand decay to false and also disables the run collision, because now we shouldn't be colliding anymore with the wall, because we're pulling back now. And this just enables it, as you can see. So that works just fine. And then what I've done is I've started to set up the IK blueprint in the anim graph here. And so this uses a power IK, which is a full body IK solver, This is a bit long to explain, but basically you have these effectors, which you specify the bone and then the position in which you want it to be, the bone to move to, basically. I've set the feet because after experiment with this, you need to have. We're gonna have to experiment some more with this because I do not know if this is gonna work right. So basically, we want these to be planted, and because this will move the entire body. This will move the entire body because it's a full body solver. So we need some static points so that they counterbalance the movement from the hands, so the entire body doesn't just shift massively. So we're gonna have to have some points that are static. I don't know if the feet and leg, just the feet are gonna do it. I might have to have the neck and the head and maybe the back or something like that static as well, but we'll see. But yeah, for now that's fine. Now here, what I've done is I basically say I've created a couple variables. This is what I want to do. So I first got an is hand IK enabled variable, and this basically says, okay, do we actually want to do any hand IK? And if that's true, then it's like, okay, well now we want to carry out hand IK, so these effectors can now actually be blended in. These effectors can now take place. We can now move the character to that point. Yeah. So okay, so I've done that. And then I've also created other variables called left hand is it and right hand is it. And this is basically to say, this is I'm going to use in the trace and be like, well, if we hit this point, yeah, if we hit this, what's it called? If our trace actually hits a wall, we want to set these values to true, and then we do the hand IK. You see what I mean? So we have one for the left and right hand. So if we actually hit it, then we do the hand IK. 2 seconds, I'll get a phone call. Okay, I'm back. So let me see. Yeah, so the left hand is here, and then that's where we want to enable it. And basically this alpha value on the power IK effector is, like we said before, do we want to blend in or off? So I use these two, then I transform them into a float, so 1 or 0. And then this will set the alpha value to whether or not we want to have it or not. Yeah, so that's pretty much that. That's the IK stuff at the moment. This is by the way, then I just basically cache the pose from the animation, local to component, because this is done in component space, and then we transform it back to local space, output cache, and then we get the cache of that, inertialize it for blending, and then put it in the output pose. So that's what we do, really. Now that is pretty much up to date with where I'm at. Let me see, is there anything in here you need to know? Basically, I've just made a load of functions in here, like this, like enable hand IK, enable run collision. This is just all C++ stuff, to basically get whether or not the hand IK is enabled. So that functionality there. But now we can actually start to do the trace stuff, I believe. If I'm not mistaken, we can now do some trace. Can we? Well, let's see where we're at first, actually. Let's see how it's behaving. So, you see here, does the collision. Yeah, it doesn't do any hand IK. Oh. Okay, that's not ideal. So we're gonna have to, that's a bug, which we'll fix. Ah, okay, so that's also not good. Okay, so I tried to do a cap pass, and then it went into that. So that, I think, is actually with the trace itself. So, damn it. Just come across bugs all the time. Okay, no, that's fine, that's fine. Basically, we just need to, oh, that's absolutely fine. That's not even a problem. That's actually the easiest thing in the world. Basically, so if you see what was happening there, is if I was in parkour, you can't see the controller on the screen. Actually, let me, one sec, let me get the controller up. Okay, cool. So, it's gamepad view here. Let's get this up. OP. So here you can see, enlarge it a bit. Okay, so you can see how what I'm using. So now if I activate parkour mode and run in, that's fine. Like it does the collision, but I really shouldn't, because now if I do a jump, it then does a collision. So it's like, it's almost like it's stored. See there, I tried to do the jump, but yeah, okay, yeah, okay. So that's wrong. So basically, we need to only enable parkour mode. No, only enable the run collision if we're not in parkour mode. So all I'm going to do here is do and is parkour mode enabled. We already have that function, but we have to say not. So and is parkour mode not enabled. So build that. That should fix it totally. Really easy fix. Oh, let's see here. Am I recording? Yes, I am. Just gotta keep checking because I do not want to have to do this again. So cool. Now we play. Let's get this up as well. Now if we run, does the collision. Cool, cool, cool. Run here. Okay, some problem there. Okay. So it seems it's behaving very weirdly. Okay, so it's still doing the collision. Okay, that's wrong. So there seems to be something wrong with the transfer into the state. It seems that the transferring in here is something here. Now, let me think. I think it might be because, but it shouldn't even enable this. But then it comes out and then does it, even if we're past it. It's behaving quite weirdly. Let's see here. So you go. Collision. Collision. Now if I run with parkour enabled, it shouldn't do it. Nice. Okay, that might just be some stuff. We've got some collision capsule stuff to fix up. That's fine. Okay, so that does what we wanted to do, really. Okay, so that, now we're here. Oh, it does the thing after the. So, that was definitely wrong. Okay, so I think at some point it's. It seems to be doing it after. So let me think. How can I approach this? How can I fix that? What if we made like a threshold? What's the best way to approach this? You know what? Let's do this. Let's do this. So we have the trace. What I'm gonna do is basically I'm gonna make a little threshold for which we can only do the trace if we are within that threshold, so that the hit is like in front of it a certain distance. So Let's make a variable, private of course. I'm going to say float stop distance threshold is equal to 100 0. Okay, so you now have a threshold of about 100, which is a meter away. And if we say we have the stop distance is that if the stop distance is greater than or equal to the threshold, to stop distance threshold, then we do the collision things. So basically we check, is the how far we need to stop equal to basically or greater than the threshold in which you actually needed to be able to actually collide with the wall, while you're also not in parkour mode. Then we do the collision. So let's yeah. So it's like, oh, I need to stop 100 meters away. Am I within that threshold for where I want to stop? Like, this is the threshold. Is like the trace is further away, but the threshold you need to like the distance actually needs to be beyond a certain point for you to actually activate the run. And this value is actually quite good, because now this can control where we stop from. The stop distance is still used because that distance is relative to that, but yeah, so this can actually control how far we stop from every time. So that's actually quite good. Yeah. Okay, am I recording? Yeah. I'm gonna keep checking because I'm nervous. Disable. Okay. And now if I enable hand parkour, now if I disable that, now if I run back to it, okay, it does the animation still. Cool. That's fine. So if I go here, that's fine. Come back, go back again. So that's problematic. Go back again, and go back again. That's an issue. Okay, it seems to be behaving alright actually. Okay, that seems like a lot more correct. Okay, see, now it's doing what I wanted to do. I think that's an animation thing. You should collide at that point. Okay, you know that's an that seems to be an animation collision thing. Because yeah, I thought so. Because we basically disable collision on the capsule, and then if the mesh collides. So I think what's happening is the animation's being played, and then it's like, no, you actually do collide. That's annoying though. See, then again, is it doing what I want it to do? So that needs to be fixed. So if you're right by it, I think that's because we don't check collisions on the. Oh, do you know what it is? It's because yeah, I know what it is. It's because one of the collisions we check for the jump is the like we only okay. This is not the wall collisions. Basically jump collisions. So basically we have a hip trace, and then we have feet traces at the moment for the jumps, but we only enable the collision traces for the jumps at a certain point in the animations. Like when he's up there, we enable it, disable it, enable it. You can see in the corner when it's enabled and disabled. So what's happening is when you're right by it and you do the jump, it sort of runs through a bit because it's not initially enabled. But the reason why it doesn't do it as badly there is because the hip collides. So with a lower wall like this, the hip is not going to collide, so the character is just going to step through, yeah, and then do that. So Yeah, that's fine. That's basically, if we move the hip down, it would work perfectly fine. That's fine. We just have to add more collision capsules for our thing, which we're gonna do anyway. So that's not actually the problem we're facing at the moment. But to be fair, even still, that threshold is still quite useful, I believe. Yeah. Okay, that's fine. That's fine. That's not what the task at hand. We're gonna come back to that. Okay. I think now, I don't know how amazing this is, but I think that this is actually still relevant. I think you should only stop if it's within a certain range. Still, because that actually will solve is if like you're here and then you try and run again, you now don't do the stop animation, because instead you should just stay in idle. Yeah, and what we're gonna do is add a little tag to be like, I'm in this run collision threshold, so therefore if I try to collide again with the wall, I just stay in idle. So let's I'll do that last because that seems something external. Let's do the trace. I think that was probably the next thing we really need to do is that trace. Yeah, really, I think that trace is the next step, really. Okay, let's do it. Let's do a trace. So collision, where should we have it? It should really be its own thing. It's not really a collision, it's just a trace. Let's say traces. And we're gonna make a struct. Yeah. So f hand trace. Yeah, because what we're gonna do is we're gonna make a struct. Yeah. That is what we're gonna do, people. We're gonna make a little struct. Because a struct can because there's a couple things. Okay, yeah. There's a couple things we need from the trace. The things we need from the trace are these variables. We need three things. We're going to make this trace used for both hands, so we're not going to make a left hand trace, right? We're just going to make one trace. And we need three things. We need the effector location, so that's basically where I hit, the hit location. We need whether or not it has hit, so that's like, is there like a hit on it? And then we need that's it, really. I think that should be it, actually. That's all we need, really. Is it not? Yeah, just whether or not we have hit, and then the hit location. Yeah, that's all we need. That's all we need at the moment. Cool. So let's do that. Let's make that struct, because this struct is actually going to hold the output values for the trace, as well as have the trace function as well. So, but it's not actually going to be in the struct. Here struct. So we're going to have an f vector, which is going to be the hit location, which is basically going to store the output location, which is going to be our effector location, basically. Let's call it effector location, because let's keep it. Actually, no, let's say hit location, because it makes it more relevant to a trace and less to IK, because this hand trace may not always be used for IK. So let's keep it verbose, and we'll just set this to like the null for 0 vector for now. Cool. And then we also need whether or not it has hit, so that's going to be a bool. Bool has hit is equal to false. Cool. So that's our struct. Oh, bless me. Okay, cool. Now let's make um yeah, so now we want a function that's going to return that f hand trace, and we'll say the function is called a hand trace. And what we're going to take in. So what do we need for the line trace? Okay, we're gonna need a couple things. So if you see in this line trace we have here, we have stuff like get world, hits and all that stuff, and we get like component location, because we're gonna need the socket location of the hand that we're tracing. So what we're gonna need here to get that socket location, we need actor, because it's gonna be get actor location. So we're actually gonna have to add a pointer to a character or actor. I think actor is inherent of character, so I'm gonna say character. Well, it should really be ASPP character here. A pointer to that, and that's gonna be the source for our basically get world. We're gonna use that source to basically be able to access all the character like methods, so like get character, get world, get socket location, all that stuff. And then we need the socket name, which is the socket that we're going to use. And what do we need? What? We need how far we want to trace, I guess. Do we need that? Is that relevant? No, that is relevant. Yeah. So we're gonna because basically, do I want to pass that though, or do I want to make it constant? No, let's pass it. Let's pass it, because different traces might want to be of different lengths. So like if you're doing like a certain animation, you might want to do just like a small trace. So let's actually pass the distance. I'm also gonna get rid of that, and instead I'm going to use a character. Now, ASPP character is what we use at the moment for our main character class, but it inherits this. And what I'm going to make it a character is because this hand trace then can be used for multiple different characters, not just an SPP character. Yeah, so this makes it way more like usable throughout, so it's not limited to or tied to that, because it shouldn't be, like, really. Okay, so now in our C++, we've included that. We're gonna need some. I feel like we're gonna need a lot of things. A lot of functionality. We're gonna need like some math stuff, because we're gonna have to make some interesting decisions about how we're gonna do the trace. So, how do I want to go about this? You know what I'm going to do? Where's our collision trace? I think we do capsule collision. I'm just going to copy this. I'm just going to take all these includes, and then whatever I don't use, I'll get rid of. Yeah, we definitely don't need that. Cool. So now, let us do f hand trace. Const a character. Can I just generate implementation? Nope. Okay. Source. What is that about? Comma f name, socket name, comma float distance. Okay, now what do we need to do now? The trace, really. I think that's about it. Yeah, I'm gonna return it. Relax hand trace function, I'm coming. Okay, so what do we need? What do we need for this trace? Let's get all our variables. So we need the start location. We need interesting. You know what I'm gonna do? I'm gonna do we're gonna get a start location. That's the first thing. Well, the hand location. So we'll say it's gonna be a vector. You can use auto to basically like just auto complete the type, but you should really use the actual type you're gonna use. It's just so much better. Let's say hand vector, hand location is going to equal source mesh get mesh and then get socket location. Haha, socket name. Cool. That's lovely. So that's the location of the hand. Now we need a vector to store where we want to start. Where do we want to start? See, now normally I would just make the start the hand location, but what I'm actually gonna do is, because the walls in which we want to place, I want to make this trace a bit more for universal. So if you see here, like the trace, we'd normally just do it down to that wall, but if you come to this wall here, what if the wall is slightly bigger, like here? A trace down would be useless. We need a trace upwards as well. So like, see, like, is the wall higher than where we are? So what I'm gonna do is, rather than do a trace upwards, which I'm not actually gonna do, that's an extra trace, I'm gonna increase the start. So source, we want to get the down vector, up vector, get the up vector, get actor up vector. There you are. And I'm gonna, so we have the up vector. So watch which direction it is. No, that's not right. That wouldn't do it. Sorry, I'm thinking this through as I'm going as well. I don't wanna. That would just say the up vector. So we have the up vector. Okay, cool. I want to multiply that by the distance. Yeah. So we're gonna trace however that far up. That's what I'm missing. We have to do hand location plus that. So we have to add the hand location to this up vector times by the distance. So the location will move up however far. So the start of the trace is above the hand however far, and then we'll make the end of the trace below the hand however far. Cool. Am I recording? I'm gonna keep checking this the entire time. 38 minutes so far. Guys, getting along. Times by the distance, and then we'll do times by -1 as well. Cool. So the trace start and the trace end should be now above and below the hand, if I'm not mistaken. Yep, that makes sense. Okay, cool. Let's do the trace now. So we need f collision query parameters. I will name that params. I think that's what I do in the other one. Params dot add node actor. And then we're gonna say source because that's the actor one to ignore. I'm just kind of remembering this off head from in this. Is that correct? Is that correct? Nope, I don't use it in there. Where do I use it? I just want to check because I could just be writing stuff and it's just wrong. Yeah. So I use this, but I need source. So I was right. See, I'm getting good at the C++ thing. We'll say that now. Now what? I don't remember. The hit function. Yes. F hit result hits. Yeah, we'll keep it out of hits. Good old line trace now. So source line. No, get world. line trace single by channel hits, comma trace start, comma trace end, comma trace channel. Where's the trace channel? Trace channel parameters. I don't remember what I did. What did I do? Ah, these. Gotcha. Why didn't I just copy the thing? Here we are. There you go. Cool. So that's our line trace. Finito. Now what? Now we need to return the trace result. Ah, we can't just return hits. No, we need to return the struct. So we say, let's create struct first. Fhand trace, trace result. Say trace really. Let's say trace result. And then we say trace result dot has hit is equal to hits dot the get the blocking hit. That's a boolean, like where this basically means like whether or not there is a blocking hit, so that's true or false. And then we'll say trace result dot hit location is equal to hits dot location. That's the location of the hit, and then we're going to return trace result. Bingo. So that is that. That is that. So that's our hand trace done. Load of things we don't need here, but I'm gonna just leave it for now. CBA. What else do I need? What else do we need? I think that pretty much covers it, you know. I think that pretty much covers it. So now let's go in here. We now need to basically call this function. And what's interesting, because this is an anim graph that we're going to use it, this needs to be blueprint callable. Does it? Yes, it does. Yeah, because we want to have the hand trace in the actual anim graph here. Oh no, so yeah, we need to get the vector here, so we need to have the thing callable in here, so we can make it callable in here. So yeah, cool. So that's full. That's fine. That's fine. So let's go in here. Let's go make some functions. We'll do it after this one. So we'll say u function blueprint callable f hand trace. Oh, that makes sense. We haven't included it, so we need to include that. Include f. We'll do it properly. Human motion. What? What? Where is it? Why is it not showing up? Oh, character animation traces. I don't know if I like that being there. I'm gonna move that to that. Yeah, and now it's out of the notifiers, back into traces. Let's get rid of this. Yeah. Yeah, cool. Do I want it in character even? I feel like it should be a trace. A trace should be separate. No, but it's a character. It's a hand trace, isn't it? Yeah, it's a hand trace. Let's be honest. So that should like you ain't gonna do a hand trace on something that's not a character. So yeah, let's keep it in that level. Now we can go back here. Let me say F hand trace. Yeah, there it is. Hand IK trace, because that's what this one is going to be used for. So this trace is going to be useful for this character at least. Is equal. Wait, no, it's a function. I'm not doing. What do we need? We need the name. And the distance, because that's what we pass to. Oh no, we also pass the source. Ah, but we don't need that. That's fine. Now, so basically, I'm gonna just use this function to call that function to call this function, but I want to keep this away, hidden from this function, because I don't need this function. Doesn't really need to know it. Like the blueprint function doesn't need to pass it a target. It just needs to pass it because we're just going to use the whatever class it's in. So we just need this in the distance. Yeah, cool. So that's that. Nice. Generate implementation. Lovely. Yeah, I know there's no ruler. Give me a second. These guys don't give me any time to breathe. You know what I mean? You know what I mean? Okay, so I guess we're just gonna do the hand. Oh no, hand IK true. No. I think. What are we doing now? Ah, now we do the actual trace itself. So that's the hand trace. There we go. With this socket name and distance. Return this. Sweet. So that should now return the struct that is this, and that is what this is going to use. That seems right. That seems pretty right to me. What? The huh. Okay. Okay, so let's go back to it. Okay, so we got a problem here. I knew there'd be an issue. So unrecognized type F hand trace type must be a U class U struct U. Is that yeah? So that's because it needs to be blueprint callable. Yeah, I had a damn it. I knew it had something to do with that. So we need to make it a U struct. So structs need to be basically blueprint exposed, I believe. I think we need to make it so that this can be exposed in blueprints, because obviously this function is blueprint callable, but this structure that we use needs to also be able to be exposed in blueprints. So that's in here. How the hell do I make a U struct? I ain't got a clue. There we go. So we don't have that struct is hand trace. fix it? It does. There we go. Nice. Ah, yes. Forgot about that for a second. Fuller sign's gonna go wrong. Oh, yeah. Missing type specifier. Is not a member of hand trace. Use type. I'm giving it the type. Is there like a blueprint type? Let's have a look around. Research, try and find someone that uses a ustruct. What uses a ustruct? We must have something here that uses a ustruct. Aha, this. What's this person struct? No, that's not what I was looking for. Project scope. Aha, this is what I want. Okay, here we go. Ah, these are redundant. Key property before every variable. Generated ustruct body. I don't know if I need that one. Ah, that's it as well. Yep. Okay. I knew it. It's because I don't include f handtrace dot generated dot h. I knew it. That's a big factor. Yeah. So basically, whenever you use a struct like that's blueprint, I think you have to include the generated file for it. I'm also gonna add this uProperty stuff because I think. Ah, okay. So this specifies. Okay, here we go, guys. Look, ustruct tutorial right here. So this specifies the type of blueprint variable it is. So you can be like blueprint read and write. That's just for a function. You want it read only. Okay, cool. There we go. Okay, I think that should work. That should be fine now. That should work. Ah, yes. Lovely. Cool. So we got our struct going. We got our struct going. Oh, yeah. Okay. That's fine. We made a lot of changes to code. We've got a trace. The trace. We have a function for the trace now called hand ik trace, which takes in the socket name and the distance. I kind of just flew through this without really checking my own code, but let me think. It takes in the socket and the distance. This then does the hand trace on this, the socket and the distance, blah 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 blah. Cool. That's right. Let's now we can set the variables we made. Awesome. So let's go in here into our local adding graph. In here, no, into gather here. Let's why is there a Why is there an extra node? See, this is what happens when you have so many linking. Why is this there? What's going on here, man? What have I done? I know there's a shortcut to do that, but I don't yet know what it is. I like do it occasionally. I should just look it up, but I'm lazy. Let's now 15. Let's see this. Just got another reroute node. Now we need to get this guy here. Get the character. And bingo. Socket name. Ah, I see. So we need to do this for both the left and right. Yeah, so we need to do tree traces to set all these values here. That's cool. So distance, we want, let's just do a trace of 50. Socket name, hand underscore left. And then we'll set, this should now be able to split. Boom, look at that. Oh, it's actually nice. It's nice when you get good code. When you get some code working, it's always nice. Let's do sequence, just to make it look nice and organized. That, because you know me, I like to be super organized. You know, I'm the most organized person. Left hand, nope, that's wrong. Set left hand has hit there. That to that. This looks incredibly messy. I thought it'd be clean, but it's really not. Actually, no, that's fine. That's fine. Do it like this. And then you add another pin. So we set left hand effector to the hit location. That's where we want to move it. Right hand, left hand hit, whether or not it has hit. Cool. Then now we need you again, the character. IK trace. Same thing again. Now we're going to do that to that. Yeah. And then we do the right hand. Let's go R. These should all be variables, really, but that's another person's problem. Nah, it's still my problem, to be honest. I'm joking. Split this struct. Set that. Then we'll set this as well. I kind of realize how much I talk to myself when I do this. It's kind of weird, but you know, hey ho. Let's do that. There we go. Cool. So that's that. That should do it. We've got the IK set up, so it does a trace. We have hand has hit, so and in the effector location. This should now work. Moment of truth. My life. Why does it not work? Huh? Why don't you want to work for me? Oh, hold on. That worked. What is going on? Okay, it did it. It did do it. It did do it. Come on, man. Like, I saw it move the hand there for a split second. No. This works. This does work. Do you know what it is? That works. It's the trace. That's what it is. It's the trace. It's nothing's colliding. It's the trace. Yeah. The trace on the hand is is not colliding with the wall. Because if you see, if I come at an angle, and which means the hand's further forward, because the actual hit location is gonna be fit, it does it. Yeah. Okay. Cool. It's the trace. So the trace here doesn't seem to reach the wall. We can't just move. Okay, you know what? Let's do this. We're gonna make two traces because I don't want to get rid of this trace. Because initially I was like, oh, let's just move the trace forward, but you can't really do that because what if the wall is actually by the guy's hand? Because what's happening here is you can see the capsule is stopping it from colliding through, but the hands in the animation don't reach far enough, so the trace doesn't happen. So the trace doesn't actually collide with anything. If we could debug, we'd be able to see a lot better, but we can't. So what we actually need to do is let's make a second trace. Let's do two traces. We'll do one from the hand and then one ahead of it, and then those two traces will allow us to basically check where it is. One sec. Let me check. Okay. Yeah. To be fair, I knew that was going to be the case as well. Damn it. Because Dado mentioned that to me. When we were experimenting with this, he did mention actually that we might need to do two traces, because when we were doing the animation, we saw, because we were working together on that collision, and we were like with the run collision initially, and me just being stupid, I totally forgot. He mentioned that we might have to do two traces, and he's like, move one trace in front of the other. Yeah. Oh, brain melt. Yeah, so that's cool. So that's what we have to do. We just have to do another trace. That's totally fine. So yeah, let's do another trace then. Let's do that. Yeah, cool. So okay, what we're gonna make this instead is we're gonna make this the first trace. What is the refactor? Shift. No. There's a thing you can do to change the name. Yeah, Shift F6. Shift F6. Shift F6. Oh, now I type in the name. Base. Oh, yeah, it was working. Oh, so much easier. Magic. Cool. So, let us now. Basically, this is gonna stay the same. We just need to move these forward. These the start and the end of the trace. So we can leave that. We'll need another array. And actually, yeah, so we have this, and so we have our base trace. Okay. Well, let's do our second trace. So before we return anything, let's do our second trace. And we're gonna need basically this again. Yeah. So we have our base, and then we have our secondary, and then we have our second trace, which is the second hits. I don't like second. Additional, that's a bit long. Alternate. Let's just leave it at second hits for now. No, let's say alternate. So alternate. So this is that. So this is like, if this one doesn't hit, we have this one as well. So it's the other option, the two different hits. But then that's not very verbose as to like where it is in the world. Further. No, let's just say second. Second hits. We need some new parameters though. Yeah, so we need basically some like new start locations. So second trace start. That's actually fine because all we're gonna do here is is equal to the trace start, and then we're gonna add the forward vector times by however far we want forward. So we'll do source. What the get actor forward times what the hold on. Sorry about that. I had to move my mic real quick. People are absolutely screaming down my street. I swear to God. You know, maybe you're trying to work from home is stressful sometimes. I realized, well, a lot of time I wasn't being very good. I wasn't using 20.0 for some of my stuff, so just make sure I use that. You know, just to be like, proper with my code. It's basically just to specify. It's like that's a float. Yeah, so that should add the forward vector to the trace start and move it forward 20. And then we do the same thing for the trace end is equal to trace end plus source get actor forward vector times by 20.0. Cool. Okay. So that should be our second trace. This also needs to be second hits. And that should be second. Cool. So that should now do it for our second trace. Oh no, we need to store it. So we need now hand trace, second trace, and then we do second trace dot has hit is equal to second hits dot be blocking hit. Yep, and then we do the same thing again. Second trace dot hit location is equal to second hits dot location. Anything else we need there? Yeah. Yeah, that seems pretty correct actually. Trying to think. Yeah. And now we need to return, but we need to make a decision which one we're going to return. So we're going to return. let's do an if. I was basically gonna say if base trace, if this is hit, then we're gonna so if this is true, so it has hit, the base trace has hit, return this. If not, we want to return this second trace, because that's the most forward one. They could both still be null, but if the first one hasn't hit, we need to return the second one. So let's go through. Let's do this. Let's do a base. We're gonna do a fancy if statement again. Base trace dot has hit. If that's true, yeah, then we want to return base trace. Otherwise, return second trace. Yeah. So if this has hit, we return that. Otherwise, return that. Yeah. Seems pretty cool to me. Seems all fine to me. Yeah. Cool. Build that. That should work. I don't see why that wouldn't work. Let's see here. Come on. Yes. Ah, you beauty. Okay, that's fine because we hear. Ah, sweet. Perfect. That works. That literally works. That's the IK working. Obviously, his hips look extremely weird. But that's because some bone positions are being pulled in weird ways. So we need to add some more effectors, I think, in like the shoulders and maybe the head and things, so they don't all. And then we add some smoothing as well to the moving of the IK. So that's fine, but that's experimenting with the IK itself and that node, with that power IK node. But the actual logic of the IK seems to be pretty spot on. And we can't run again. Yeah, cool. We need to basically disable that because obviously it's within threshold, and this is what we're trying to avoid. So I need to actually do it so that it stays in idle. And I'm gonna do that, but I'm gonna go eat first because I'm starving. And I also might just make that a separate devlog because I'm wary this is quite long at the moment. But yeah, so character runs up. See, that's we got to fix as well. Clearly it's still in the state, so that's something to do with the enabling and disabling of the run collision. So character runs, place on the wall, comes back, high K is disabled. Yeah, so really we just need now some smoothing between the two, some more effectors to keep the positional values of the body a bit more constant, and yeah, that's because obviously this is full body, so it pulls the hand. But yeah, that's pretty ideal actually. I like that. I like that a lot. That's cool. One other thing that I think I made a note of that I needed to do as well. I'm trying to think what it was. Basically, we only let me check my notes real quick because there's I think there's one or two other things I wanted to do today that I think with the trace that I would 2 seconds. Okay, so it's what I went to do earlier. Basically what we need to do is we need to check that the trace, basically there's literally one last thing that obviously I have a load of work to do with smoothing and stuff, but one last thing I'm going to include because it has to do with the trace, and I'm like, let's just finish this stuff off. I'm pretty sure we need to check and only return has hit if it hits a flat surface for now. Although to be honest, yeah, because we're using the actor up and down. Okay, yeah, no, that's fine. yeah, and we want it to be flat relative to the, because we're not doing any rotational values or whatever, things like that. That's fine, that's fine. I think any rotation is going to be done separately. So really we just want it to plant on flat surfaces. So we basically just need to check whether or not the collision, the hit, is on a flat surface. Which, what we're going to do for that, yeah, that's actually pretty easy. That's actually pretty easy. Yeah, that's actually really easy. So basically, this trace is only going to be valid, yeah, if so it's actually only going to say has hit if the surface, okay, you know what we're gonna do? We're gonna create a variable that's like is surface flat, and that's going to be a boolean, and this is basically going to tell us whether or not whether or not the result from our hit is whether or not the result from our hit is it's on a flat surface. So we need to get the normal, and then we're going to compare that with the actor up vector. And then basically if the math thing, two vectors of dot product, because the dot product calculates how much of one vector goes in the direction of another vector. So if the dot product is basically, if the dot product is 1, then that means both vectors go in the same direction. But we'll do like 0.9, because that means this is like Dado mentioned this to me as well. It's like if it's like 0.9, it means it's pretty much in the same direction, and it gives a bit of flexibility. So if the dot product is greater than 0.9, then it's going in the same direction. And the normal is basically like where the trace collides, and where the trace collides and shoots back up. It's like, is the surface like is the if you think of it like as a ray, if I shoot from here to there, is that like a draw feature? Should I explain it to you? So if you think of a ray, if my collision is going like this, down in this direction, the normal will reflect it like in however back at itself, depending on how it went. So if we went like this, normal would be like there. So if we went like this, the normal would be like there. So, and then the normal of it would be like that. So what we're then gonna say is if the normal, so this little arrow up here, is the same as the actor up vector. So we have our, get rid of all this, oh god, it's very small, get rid of all this. So then we say, if we have our actor up vector, so we have our little man here like this, he's chilling, he's just having a good day, and now we have a hand here, and the trace is going down like this, but his up vector is like that. We hit an object here, the normal is at this point here, but we're going to pretend like it's over here, is going to be going up there. Then we're going to calculate the dot product of this vector, which is this guy's up vector, and this normal, and if that dot product with that is greater than 0.9, that means they're pretty much going in the same direction, and therefore they're both up, and it's pretty much a flat surface relative to the actor's up location, and therefore we want to do we want to return yes, this is a good blocking hit. So therefore we want to do the IK. Otherwise we don't want to do the IK. So if it's like hitting at an angle, it's like, oh no, that's not a very good hit. It's not really something that my hand can plant on, so we're not going to do it. Really, it should be like if it was equal to 1, that means it's the same direction, but we'll just do greater than 0.9. trying to do this with a mouse is a nightmare. Look at it; it looks terrible. But you get I think I hope you get the gist of what I was trying to basically do. So we'll say this surface flat is equal to source get actor up vector dot product. How does this function work? I don't even. The dot product of two vectors, the first vector, the second vector. Yeah, cool. Dot product with the hits dot normal. Oh damn it! So you have to pass it both. How in the struct f vector? And we'll say actor up vector. Basically, that's between 1 and 0, comma hits impact normal. Yeah, pointing out from the plane. Cool. So that's is surface flat is going to be that one. The actor up vector with this. Let's just do f vector because we're just reusing a load of stuff. Like, this is just terrible code. Hold on. Oh no. See what I mean? Just so much better. The up vector and that, and then we'll say f vector. Cool. Much better. Much nicer code. Much neater code. And then we'll do this again. Is if so this is that and is surface flat. It will say and is base surface flat. And is the base surface flat? So is the base surface flat, or the base trace surface flat? Is going to be whether it has hit. Is going to be, is there blocking here, and is the surface flat, which is you calculate normal from that. Okay. Oof. And we're going to do the same thing again for this. Yep. Cool. Is second surface flat is the second, and then you're going to do the second surface flat is going to be the second hits with the impact normal of that, of the second hit. Cool. So you have that, the bare first hit, the second hit of that, and then this is going to be that, and is second surface flat. So if that is flat and there's a blocking here, then that's how it's hit, and then return whatever the values are from that. Cool. So that should now take the normal into account, so we shouldn't get any weird little. I don't really think it's going to make much of a difference because the wall in which it's going to collide is going to be, and the trace is pretty much down. What? Oh, I'm so stupid. Yeah, so the dot product has to be greater than 0.9. See? See, people? Gotta remember that. See, that's I forgot that. Yeah, yeah. It's gotta be greater than 0.9. That means it's in the same direction. Cool. Now we build. This should work. Yeah, cool. I'm pretty sure it's gonna behave the exact same way, but at least we know we've cleaned up the code and we've now added that feature that we wanted to add. Yeah, behave the exact same. That's it. Cool. So I want to call it there for this devlog. I'm where it's long. I don't want to bore you. Please tell me I was recording all that. Yes. Cool guys. So yeah, we made some hand IK, implemented that. Yeah. Now there's a lot of tweaks to fix. I want to mainly play around with this IK effector stuff. I think I just need to add some more effectors. And then there's some weird logic where like it does collide, it does the animation when it's not actually on the wall. Yeah, like yeah, see that is because it enters the state, the trajectory changes. Yeah, that's fine. It enters the state, trajectory changes, and then it comes. So if I come out, if I run towards it now, it's gonna enter the state, trajectory changes. Okay, maybe not. Yeah. So basically, I think it's when it enters the state, but just the character moves in a different position. But yeah, we'll sort that out anyway. Cool. So, cheers, guys. Any questions? Anything else you have? If I explained something wrong, I probably did. Feel free to correct me in the comments or whatever that. Yeah, cool. I'll catch you guys later.